Hello everyone. In today's lecture, we will see some of the basic operations that are done on the matrices as well as how do we write a matrix in a MATLAB. And when I say matrix, it includes both the matrix as well as the vectors, which we commonly call as row vector or the column vectors. So in the case of MATLAB, the basic computational unit is a matrix. So that is why all the variables that are assigned or that are used in MATLAB are stored in the form of a matrix. So in case if we simply store a number, then it is also stored in the form of a matrix. For example, let's say I write a equals to 4, and then if I check the properties of this variable a, I get its size as 1 cross 1. So this basically tells us that the variable a in which we have stored value 4, which is a scalar for us, is actually a 1 cross 1 matrix. Okay, so that's fine. Now we see how we write a matrix. So in case when we have to write the elements of a matrix, there are cases when we have more than one element. So in that case, how we will write the elements of the rows and the columns, and how are we going to separate them? So we see that the elements in a row are separated either by a space or by a comma, or a combination of both also. So both the things work. For example, in this case we are going to see a matrix A. So a matrix A is going to be a matrix which will contain 1, 2, 3 and 4 rows and 3 columns. So in the case when we are writing elements in a row, then we will separate those elements by space or by comma, and multiple rows are separated by semicolon or the carriage written. So 1, 2, 3 is one row of the matrix and 4, 5, 6 is the second row of the matrix. So in order to separate these two rows, we either use carriage written, that is we press enter, or we use semicolon. So like in the case when we are separating this row from this row, we are simply using the carriage written where we have pressed the enter. In this case, when we are separating the second row from the third row, we are using a semicolon in between. And similarly, when we are separating the third row from the fourth row, we are again using a semicolon. So in this way, we have seen all the possible variations here which we use to separate the elements in a matrix. So when I run this, we get a matrix which is matrix A, and this is how it will look like. So you can see that 1, 2, 3 belongs to the first row and 4, 5, 6 belongs to the second row. So even though we have not used a semicolon after 3, then also it changes the row because we have used enter in the script. That means we have changed the line. One important thing to note is that if we do not want to use carriage written, or if we want to write the entire matrix in a single line, that also we can do, and it can be done simply by just removing this. So if we put this here and we do this, then also it is going to be the same. So you can see that again we are getting the same matrix only. So it can be done in any way, whichever suits you. The method of using comma as well as semicolon is to make it clearly visible that the elements are separated and the rows are separated. Now the second point comes in our mind is what can be the elements in a matrix in MATLAB. So in the above example, we have used only the numbers as the elements of the matrix, but in this case in the matrix B, we show you that we can use even the mathematical functions as elements of a matrix. For example, in this case, the elements of the row are 1, 2 and the absolute value of minus 3.14. So here absolute is a mathematical function. So we are using this particular function as an element within the matrix. Similarly, we are using sin pi by 4 as one element, cos pi by 4 as the second element of the second row, and 0 as the third. And in the same manner, we are using square root of 4. And this important thing is that we can use any kind of math function. For example, here what we used is real of 1 plus 3i. So it will have the real value of this particular complex number, and here we are saying the imaginary of 1 plus 3i. So this element is going to be the imaginary part of this complex number. So when I run this particular section, I get the matrix which is like this. So we can see that the first element is 1, the second element is 2, and the third element is absolute of minus 3.14. That means it will give us the magnitude of the number. It will remove the sign and give us the magnitude of the number. And then we have sine pi by 4, so it is equals 0.7071. Same for cos pi by 4, then 0. Square root of 4, square root of 4 is 2, so you get 2 here. Now see that real part of 1 plus 3i is 1 and imaginary part of 1 plus 3i is 3. So we see that we can use math functions that are already defined in the MATLAB as one of the elements or as an element in the matrix. This also works.